Why does... Okay. That was weird. Let's see here. Okay, can you guys see me now? Okay. Yeah, the connection's iffy today, I guess. It's annoying. Okay, so everyone got this though, what a mole is. It's just 1 mole equals that crazy number of whatever we're talking about. So again, molarity refers to the amount of moles of the solute in 1 liter of the solution. Okay. Next thing I want to look at is what we mean by pH and acidity and basicity, or how acidic or basic a solution can be. Okay. All right, so pH is a measure of hydrogen ion, H plus ion. This is hydrogen ions concentration in a solution. That's what the pH scale will tell us. It will tell us the concentration of hydrogen ions, how many hydrogen ions are in that solution. So I'm actually going to draw the pH scale. Do it in black. So the pH scale goes from 0 all the way to 14. Anywhere from 0 to 14. And I'll put a 7 in the middle as well. Okay. So the concentration of hydrogen ions is inversely related to the pH number. It's weird. It's annoying. But you'll get used to it. It's an inverse negative log thing. Logarithm, it's as the calculation. You don't have to know that. All you have to know is that as you decrease the pH, okay, as you go down in pH from 7, 5, 6, 5, 4, 3, 2, 1, you are increasing the amount of hydrogen ions, and you are actually becoming more acidic. So acidic solutions have a high number of hydrogen ions in the solution, a high concentration of hydrogen ions. So I'll also write more H plus ions. These are positively charged cations, like we learned in lecture today. Also called, if you're looking at the textbook, might just be called protons. Biologists often do that. They call hydrogen ions just protons for short, because a hydrogen ion has 1 electron, and if it loses it, all that's left is 1 proton, and it's positively charged. So we call that an acidic solution. Importantly, pH 7 we consider neutral. So this is neutral pH. And then as we increase pH, we become more basic. And a basic solution has less hydrogen ions. Okay. So when we have a chemical substance or compound that is going to increase hydrogen ions in the solution, we call it an acid. It's going to increase hydrogen ion concentration when we add it in the overall solution. That would be considered an acid. And it's going to decrease pH of that solution. So let's say we have a solution that's neutral pH of 7. When we add an acid, the pH starts to go down, and as we add that acid in, we are adding more hydrogen ions to the solution. Conversely, if we add something that's basic, it's actually going to decrease hydrogen ion concentration. The reason this is, not to get too fancy or technical, it's because basic chemicals and basic solutions have a higher amount relative to the hydrogen ions of what we call hydroxide ions. So I'm going to write more hydroxide ions, which is these negatively charged OH molecules. I'll move this up a little bit. But essentially, these OH minus molecules kind of soak up the hydrogens and decrease their amount. Conversely, acidic solutions with lower pHs have less hydroxide. This is known as a hydroxide molecule. They have less of these guys. Okay. Now, I wanted to mention hydroxide because a solution with a neutral pH of 7 means that the hydrogens and the hydroxides are equal in concentration. Makes it a pH 7, it makes it neutral. So it's all relative. If you have more hydrogens than hydroxides, you have an acidic solution, you have lower pH. If you have less hydrogen ions, more hydroxides, you have a basic solution. Okay, so in this lab, there's going to be titration. Titration is a technique that's used to determine what the pH is. And this is how we do it. Okay, so we're going to use a chemical. So I actually bought new markers for this occasion because I need some new colors right now. So we're going to be using what we call a pH indicator dye. And we call it phenol red. So I'll write that down. And it's red, phenol red. Okay. Phenol red has an endpoint of 7. what does that mean? Well, I'm gonna tell you. Okay. Okay. So this is the 7 is the endpoint of phenol red. Phenol red is red. Now, at pH 7, we see red. Oh, I got a message. Let me just message her really quick. Okay. So at pH 7 in the solution's red, okay? As the solution becomes more acidic, if I start adding something acidic to the solution, the pH indicator dye, phenol red, actually turns a yellowish orange. Okay, so I have, where's my freaking markers? Oh. So I have this orangish marker here. So in the presence of phenol red, an acidic solution will turn yellow orangish. So yellow orange. Okay. Next, the color. Okay, well, let me rephrase. Or let me ask this question. If I'm adding an acidic solution, something that's an acid, to our neutral pH 7, and we start to see yellow-orange, our pH is increasing or decreasing? pH is decreasing, exactly. Hydrogen ions are going up. Okay. Next, we got to talk about the other situation, which is when our pH goes up and our solution becomes more basic. In the presence of phenol red, our liquid that we're looking at is going to turn pink. Okay, so again, if we're looking at an acid with phenol red, it's going to look like this, yellow-orange. If we're looking at a base with phenol red, it has a pink color. Now, titration and endpoint, what that means and how we determine the pH of a solution, that's what this lab's about. If we have an acid, we know it's going to have some pH between 0 and 7, but we don't know what the pH is, okay? The way we determine it, we look at the color, we say, oh, yellow-orange, that's an acid. We're actually going to add a base to it. We're going to add a base. So let's say, we have pH of, we don't know the pH, but let's say we have this acid and it has a pH of 4, okay? What we're going to do is add dropwise, by drops, we're going to add base. The reason It's because we want to determine how many drops does it take to raise the pH to our endpoint. Why is it an endpoint? Because what happens when we raise this pH here from 4 to 7, as we're adding base, it neutralizes the acid. That's right, it's gonna raise the pH. Bases, when you're basic, you have a higher pH. It's actually gonna increase the hydroxide ions, decreasing the hydrogen ions. But importantly, we're gonna increase that pH and we're gonna watch the color. And you'll see in Stacy's video, the color change is going to happen. It's an irreversible color change when you reach that endpoint. But the important thing that you do is you count the number of drops of base it took to get to that endpoint. Why? The reason is because if you have something that's yellow-orange, that's pH 4, and then you have something that's yellow-orange, same color, can't really tell the difference in color, but it's pH of 2. The stronger acid that has that pH 2 is going to take more base drops, more drops of your base to get to the endpoint. It might take, let's say this pH 2 one might take 10 drops to get to the endpoint. I'm just making up numbers. It might take 10 drops to the endpoint, but the pH 4 one is already closer to the endpoint. So to see that irreversible color change from yellow-orange, maybe the 4 will only take 4 drops to end point. And it's vice versa. If you have a substance that's pink, I won't go through it again, but if you have a pink solution, you know it's basic. You know it has a higher pH, less hydrogen ions. Let's say it's pH 10 or 12 or whatever. And to determine how basic it is and what the pH is, 10 or 12 or 9, you'd count the amount of drops of what? What's going to lower the pH back to 7, to that endpoint? Yes, exactly. Acid. You're going to add acid to the base to lower its pH, releasing hydrogen ions, lowering its pH back to 7 to determine that pH of the base. If it takes more acid, then it's a higher, or it's a stronger base, right? It has less hydrogens. You got to add more and more to get back to 7 than maybe a weaker base that has like pH 8. Okay, so this is a mini lecture, so I'm going to try and wrap things up quick here. Because what time is it? Okay, yeah. All right. But it's tricky, so I like to spend some time here. So this is really what you're going to be doing with a few acids first, determining or watching Stacy's video and determining how many drops of base it will take for different acids to determine the pH. Then in exercise 2 of the lab, you're actually going to be determining the pH for different body fluids. So there's saliva, gastric juice, which is in your stomach, pancreatin, which is secreted by the pancreas, and urine. And really just titrating these solutions to determine the pH of them. So it's the body fluid, you add the phenol red, mix them together. You determine after that if it's pink or yellow to see if it's acidic or basic, and then that will tell you if you add acid or base to get to titrate it back to the endpoint. The titrant that you will use if you're basic, the acid is HCl, hydrochloric acid. If it's acidic, you would use sodium hydroxide, which is a basic compound. And then you count the number of drops it takes to get that irreversible color change from yellow-orange to back to the phenol red versus pink back to the endpoint. I think that's it. Let me see, I had a question here. I think she counts the drops. I think so. I don't think she'd make you do that. But if we were in person, you would count your drops of acid or drops of base, depending on what you're titrating. And I believe Stacy will also, this is on page 7, table 4. If it's your page 7, it's table 4. She uses pH test strips to determine the real pH of these different solutions. And so you can see if you're accurate or not. You will, one last thing I'll mention, the graph. You're gonna graph the average number of drops on your y-axis. That's your dependent variable. So the average number of drops of the titrant. And then on the x-axis, you're gonna have the substance. So this is for exercise 2. So you would have a bar graph, because this is categorical. Not a line graph, not a scatter plot. And the substance would be the pancreatin, urine, saliva. What was the other one? Gastric juice, whatever. And so you would want the average number of drops, because you're going to do each one twice. Stacy does each titration for each solution substance twice. So that's why in the data table you see saliva, gastric juice, all of them listed twice, because she does it twice. This is for accuracy, just to repeat it to see if you get the same, human error. You might have missed a drop or didn't count it, whatever. You take the average of the two for each one. So you have the average number of drops, right? Which gives you the average volume in microliters. You just times it by 100, the amount of drops. Once you have the average drops, here's how I would do the graph. I would do average drops on the y-axis here on the side. And then the x, I would have what the substance is, urine, blah, 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 pancreatin, whatever. And I would color code them too, because you got for acid and base, because the titrant's going to be different, right? It's either going to be the base or the acid. So you could color code the compounds that are acidic, and then you would have average number of drops of titrant, and the titrant would be the base. A bar graph. And you will want to do the post-lab questions this time as well. Okay, I really wanted to keep this short. It's 5:20. So questions. I can stick around for questions now. I think I covered everything I wanted to. Does that make sense? It's all new, I know, but I'm hoping this with the videos should. So any questions? Oh, the journal? Well, the journal, I'll email the due date. October, I forget when I put it. It's in the announcements though, from the very, very beginning. That'll be in the email. Any questions about the lab? Really? That's good. Okay. No, you don't need to purchase pH strips. Nope. Stacy will demonstrate that part of the experiment. Okay, well, as always, just reach out, email me if anything comes up. Yeah, I think I think I talked about everything I wanted to talk about. So Thursday, we'll finish up chemistry. Canvas quiz Friday. I'll mention it again on Thursday, and I'll include it in the email. But that's it. That's it. Okay. Are we feeling good? Awesome. Okay. So I'll see you guys Thursday. Have a great afternoon.